Well, hi, good morning, and thank you for coming and joining me today. It's the last day of June 2023, and my third session with this radio. So far, I've noticed its output is very low, very weak volume coming out of the speaker, some distortion associated with that, probably all the same thing. Otherwise, I'm not aware of any serious problem in the radio here. Yesterday I tested all the tubes. All the tubes proved out to be actually pretty good. So there's no way the tubes are responsible for the poor operation of the radio. It must be something else. So today I'm going to investigate what it could be with a voltmeter and by measuring some critical voltages, B plus and stuff like that, particularly around the tubes themselves, to see if any of the tubes have incorrect voltages, and that's why things are weak and distorted. Good chance that's the case. Just before I came in here this morning, I turned on the video, which you are now watching. I was drinking a bit of coffee and watching videos. Hey, watching a video on the latest in AI. I'm not sure that anybody can keep up with it anymore, but it's pretty strange to watch something like that. This was AI and its impact on astronomy and the like, and astrophysics, I guess would be the right word for it. And then I walk into my shop and I see all this stuff. No AI in here, that's for sure. Hey, yes there is, it's me. You ever thought about that? We're all worried about this new thing called AI showing up in the world because it might wreck it. But really the first AI to show up is us, armed with these. Did we wreck the world? I don't know yet. I think we're in a process of doing that. We're sort of building it up here and wrecking it down there. Okay, not to be too philosophical. So I think it's pretty straightforward here. I'm going to turn on I'm going to use this meter over here. And we're going to look for the power supply voltage at the power supply. See what it is, and then we're going to look for it on the various tubes. Some of these tubes will have one terminal with high voltage on it, that'd be the plate terminal, and some of them will have two terminals, the plate and a screen. And just as I'm standing here, I'm not sure which are which, but I think most of these tubes have a screen in them, I think. Better put that back on. Okay, let's tip this guy up. What I think I can find by doing this is perhaps a defective resistor that's restricting the voltage that's making it to one of the tubes, or maybe a shorted capacitor, although that would, well, I was going to say that would kill the radio, but not necessarily. So let's get the voltmeter ready here. Now, where to put the ground? There's lots of things that seem, look at the kind of a crummy solder job there. Kind of gives the impression that this was redone outside of the factory, because the roughness of that solder job. Should I clip this to ground? Now I did spot some filter capacitors. Here they are. And maybe if I look carefully in here, we'll be able to spot the a chassis connection. I shouldn't really say ground, I should say chassis. Okay, a little bit of a focus issue here. So there's two capacitors there. Look back at the original capacitor, which is the brown part right on the chassis, right back in here. And we look at this capacitor and we can see one lead is connected to what I think is the so that has an insulating plate on it to insulate the capacitor from the chassis. So you can see that from above. Yeah, so you see this plate here is non-conductive, it's not metal, and that capacitor is mounted on it. The other guy's done the same way. So these two cans could be at a voltage you would rather not touch. This also suggests that there may be a technique being used in the radio to produce a negative bias voltage. And that technique requires that these capacitors not be in contact with the chassis. So in that case, the chassis is not the place to connect. The place to connect would be to, well, the shell of one of these, but a little hard to clip on to the shell. I don't think there's anything there sticking out I can clip onto. Or I got to get at the terminal down here. Now that's one capacitor. We're looking. What about the other one? The one that's here. How is that done? Two wires coming up. We have some tape on it. That tape is unraveling. Other wire. You know, I gotta fix the focus on my camera. Just bear with me for a moment here. I'm just going to keep everything running while I do this. So I'm calling up the dialog box for the camera. Oops, what happened to it? No, I'm not calling it up. There we are. Well, we're looking at this thing. Let's look at this thing. Well, it really looks like coils wire right in here. With a big metal bracket slapped around it. It doesn't make a lot of sense. It looks, you know what it could be? Wire. That could be a wire resistor. This could be a wire wound resistor of a sort I've never seen before. Number 33 something or other. It's quite likely what it is. Okay, we'll go on that assumption. It's a wire wound resistor. Now back to what we're looking at. Where do we hook up the ground for the voltmeter? So looking at this other capacitor now. There. There's the lead. Okay, and it goes over to, oh, well, that would be pretty obviously a connection to the chassis. Look with my own eyes. Yeah, it's right on the main chassis body. So we have one capacitor grounded to the chassis. How big is this capacitor? Can we find that out? Maybe it's a bypass? No, it wouldn't be. I don't know. Okay, don't mutter. You can see clearly too the old capacitors leads are cut away. It's not in the circuit in any way. Now that's one of them, and the other one's down here. It's just cut away and done away with. So even though they're sitting up on top, well, I suppose if I could study a schematic, I could sort this out a little bit better. Wait a minute. Wait 1 minute. If this capacitor is tied to that terminal and on there, but that capacitor is tied to nothing, the original one is tied to nothing, what is that capacitor hooked up to? It's just hooked up to the shell of the original capacitor. Well, that wouldn't be right. That wouldn't be right. I like to say things twice for emphasis sometimes. Well, it's a mistake that could easily be made. Somebody could look at that and think it's coming through the chassis. They think that they're soldering to the chassis, but they're not, because that simply connects to the shell of this capacitor, which is up on an insulator. Oh, that's interesting. When I encounter something like this, the first thing I say is, no, Jim, the last guy knew what he was doing. You're just making a mistake you haven't figured out yet. So I think we're just going to leave that as an odd observation. The little voltmetering in there will tell us what's going on with this capacitor. Because basically only one lead is hooked up into the radio and the other lead is hooked up to space. Okay, so then we would end up, the radio would end up being dependent on this capacitor, which I assume that's the negative going to the chassis. But then there's another whole capacitor hanging up here. This one. Now this one, sorry for the bad camera work here. So this one's clearly one lead to the chassis, but this is the sub-chassis. This is the, can I call it the tuning sub-chassis? And then, let me move it here. Well, I can't. Yeah. What's going on down here? Stick my finger up from below. Okay, it's just the way the camera is. So there's a joint there right in the middle of the circle. You can see the solder joint. It's just oh my gosh. I'm trying to see if that joint actually has three wires in it. I don't think so, though. Just spin it around, look with my eyeballs here in 3 dimensions. Yeah, it's I still can't tell for sure. Hold on a second here. Sometimes you can't beat just looking at things with your eyes. I'm going to do that. I guess, in a sense, every time you look at something, you're using your eyes, aren't you? Okay. I don't know what to make of that capacitor at the top yet. I have not found a schematic for this radio. I haven't looked that hard yet. Well, we can just investigate each of these capacitors and see what's on them to start with. Especially this one, which I wouldn't be surprised if there's nothing on it. It's a big zero. It's a goose egg. Not a chicken egg. A goose egg. Okay, so again, because of the grounding situation, even though the radio is plugged into an isolation transformer, I'm going to do these tests not with the voltmeter over here, which is plugged in the wall, but this one here, which is just a battery operated voltmeter. I can't get into trouble. Well, I probably can if I work at it. I'll try not to get into trouble. So before putting the power on, I'm going to practice this a little bit. So I'm going to want to, for instance, go on the chassis. What do you got there? This is the chassis. And the other, oh boy, the wires just disappeared in here, under here. So white one's coming down. Oh boy, it's just, oh man, it's all caught in behind there. Wow, Okay, so I want to get on the positive lead of this other capacitor, and it's all covered up and inaccessible as far as I can tell. This is why I like to practice these things. Better to find this out with the radio not on than to have the radio on and start doing this. Okay, so no question, it's coming up here. It's coming up onto the power cord. I really like seeing these things along their absolutely entire length. This wire, this whitish wire here, is actually part of the power cord, and the outer covering's been stripped back to reveal the two leads in the power cord, and one of them has been just wound down under this guy here and then up onto the capacitor. Does that make sense? Once again, it's not making sense to me. First thing I think is that's because I'm nonsensical. That's me. Maybe I better look for a schematic here a little bit further. I mean, I can do the test, but I'm just not quite sure how to interpret what I'm going to get. I think I'm better off. Well, let's look at the switch here. So the on-off switch is right here. This is the one wire coming from it. You'd, I don't know if you can see it, you'd swear it's connected to this, but in fact it's not. Wow, that's not good. That looks like it's been pushed. Just push it like that. Could have caused a short in there. I don't think it did though. Because see, it's right in line with the bottom plate. This is flattened here, so this has been sitting on the bottom plate. And what that means is, when the wire was connected, it protruded a little bit. It put the plate on, pushed the wire, and almost pushed it into a short circuit on this terminal. It's a close call, I would say. So the other wires on here, you'd think this would be going to the power cord. Oh my gosh, look at that. Let's see if we can follow it here with this camera. This is the wire. And it's going way up in behind there. Curving to the left. And going around. So this black thing here is the this thing, you can barely see my finger touching it. That's the can of the big transformer. So it's kind of curving around the back of the. It's going into the transformer. I think it's going into the transformer here. That would make sense because that would be the primary. Okay, let me just. Pretty sure that's where it's going, right through a hole, right there. The wire in the front is not the wire, it's this wire, that's this one here. But it also looks like it's heading to the same spot. So, it's going in. Well, that makes sense. Okay, so that's the primary. Then the wire would come out. Then the wire coming out would be the other primary. Where did I go? This one here. Am I right? I looked away. So, okay, this guy, where's he going? He's disappearing behind this block here. Now this black thing is a classic Philco capacitor block. So inside here is 1 or 2 or 3 capacitors, and those are the terminals at the top, and the thing is filled with compound. I've never cut one open, but heard stories. That wire, if it's just going behind the block is quite narrow. It's going behind the block. That would be it popping out at the back there, way at the back. And then it's curving, it's coming up and curving around and arriving at here, which is the capacitor block. I was just worried about the short circuit. I can get a closer look at what was going on. And so then on the other side, the wire continues. It's now a black wire. Black wire. Where are you going, man? Ooh, what's that? That looks like a solder strike. Soldering iron strike. And look at that pointed thing, kind of pointing at it. You kind of put those two things together. Where am I? I'm up here. Can this come down and hit this thing? Whew. Well, that's pretty unusual. What's going on there? Okay, carrying on. And it's, oh my gosh. Him and all his buddies are disappearing here. It looks like through a hole. Oh, we're not going to be able to trace that any further. Boy, am I in need of a schematic here. The last radio I worked on had substantial changes made to it by a previous guy. A fantastic thing he did. Really impressive. But for me, as a repair guy, if somebody's come in and just done stuff of their own thinking, if they made this kind of mistake back here, if this is a mistake, what have I got in front of me here? Empty terminal. Where was that once going? Well, maybe nowhere. That's actually not really an empty terminal. That's the wire coming up out of the block, and it's soldered on a small terminal, and then the capacitor would be built in the shop that way and then stuck into the radio here, and then they make the connection up here. But look, it's no, that's one piece of metal. Oh no, it isn't. It's actually a bolted down connection. Huh. Oh boy. Okay. What am I going to do? I'm going to stop and have some coffee and think about what I got to do here. Obviously a schematic would be good. I don't know if I want to spend the time hunting for one right now. I got my voltmeter warmed up. I got my other voltmeter switched on. Coffee. Well, my hunt for schematics not going well. I have this book here. Beatman. If you look in the front under Philco, you see a whole bunch of numbers. This one's numbered 37 dash, I forgot, 610 or something like that. Not 610. Oh, 610. No, 30 something. I can't remember the number. But it starts with 37. You come all the way down here, and then all of a sudden there's a whole bunch of 37s. Now, is there a 37, 3, whatever it is? And the answer is no. I think it's 310. No, it doesn't show up. 37, 33. What was that number again? Let me just bear with me here while I quickly check. 3610, which is a 4-digit number. So maybe it's just 361. In fact, there's no 3 anything here. So this book is from 1926 to 1938, and I'm guessing this is 1937 based on the numbering. Not showing up. When was this published? I don't know. I have another old book of schematics, but it's a different range, different date range. Not a Beatman. Okay, I really want to try to find this. I'm going to look some more. But a quick peek at the smoke situation today. So today is the 30th. This is 4 o'clock in the morning starting. And this is about now. I live right in this area here. Now this is all forecast. So it looks like it's clearing out to some degree. Uh-oh. Nope. Coming back in. This looks a couple days into the future. There's a big clearing there. Yeah, but that's many days in the future. Their prediction would be pretty questionable. Smoke everywhere, eh? Wow. It's just hanging over top of New York here, too. Okay. Well, I had some luck. I found 2 references. Here's one showing pictures of the radio. This is what it looks like. This guy's all excited because he got a set of knobs for his radio. Okay, but over here at Nostalgia Air, I found the actual schematic. Excellent. 373610, right there. Radio College of Canada, so this was drawn at the Radio College of Canada. And so, yeah, it looks like they've actually, well, no, I was going to say, look, this is the separate part. No, I don't think so, not quite. So those are the right tubes, all the correct tubes, the 5Y4. There's the tube layout. That tube layout matches the radio. And all kinds of secrets here. There's the filtering on the power cord, and almost certainly this is one of those capacitor blocks right here. We see a line going to that symbol, which is almost certainly the chassis, soldered to the chassis. Here, 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 all over the place. So now we know that everything is soldered to the chassis. Let's take a look at how they're doing the filtering here. So we're coming out of the high voltage rectifier. This will be the field coil in the speaker. This will be one filter capacitor, and this is the other. They're small, 12 microfarads, 8 microfarads. Let me zoom in a bit here. They're small because the inductor has a very, very powerful effect on filtering. So you don't need big capacitors. Here's that weird resistor. It's probably a wire wound resistor I was talking about. So we can look at how this is grounded. Now it's grounded way down here. And this would be, I got silent. 9,000 ohms. Well, off, on, nothing, and tone, probably a tone cut, treble cut here, probably. Tone control, ground on the far side of this resistor. Earlier I'd mentioned about a trick they can use in the power supply to generate a negative voltage. If that were the case, this symbol would probably be sitting on this line here. How's this helping me? I'm trying to figure out. Well, okay, look at this capacitor is grounded to the chassis, but not this one. This one is up high, on the high end of this resistor. So you have one capacitor that should not be grounded. And I believe what's in here right now is one capacitor not connected. It's hard to believe, though. If you didn't connect this in, I think you'd have a pretty good hum in this radio. I think you can get away without not having this here, especially if we follow this line up. See where it's going. So it's a plate line. So on the grid side, it'd be a little more likely of a hum, but Still, my observation is this isn't done right. But this one, if there is a capacitor in there, one leg goes right to the chassis, so that's got to be this guy. We'll have to assume that this is this guy here. So I can connect on the chassis and start reading voltages in the radio and get an accurate impression of what they are. Look at the cathodes on the tubes, Jim. You see the cathodes are grounded right to the chassis. That's another powerful indication that I can do that. Very good. Okay, that solves that, and now I have a schematic to work with too. Fantastic. I'm way ahead. Any special notes? Let's just peek at the notes here in case there's something. 470 for a IF frequency would be a bit unusual. Adjust compensators. Just all detailed instructions. Second harmonic of the receiver oscillator. What? What are they talking about there? I don't know. Don't worry about it now. First peak is caused by tuning to the image. It must be neglected. Wouldn't ignored be a better word there? Ignored? Neglected. Okay, no special instructions that I see having to do with this radio that I should become aware of right now. Direction of rotation. Did they hide any other hints over here? No. There's the IF again. Tuning condenser. Oh, they don't stand out on this schematic very much. This is the oscillator part. This is the antenna after, or front end. Look at this switching arrangement here. Switching in and out of all these coils as you change bands. Oh, there's information on what's on the back. Oh, let's look at that for a minute. So the red line is switched onto one of these coils, the primary side of the transformers here. The black one is going to the other end. So that sounds like a loop antenna connection. Now what's going on here? This is grounded. Why would you want to ground that? Grounding the center. The center. So ground. So what's number 4 for? Where would you hook up a long wire? Where would you hook up a loop? The loop could go on here, but if you want to use a long wire, I think what you would do is you would connect to pin number 4. You would open the link, hook to 4. Would then the antenna signal would travel in here. Kind of goofy what's happening in the transformers here. Would not find a ground. This is just, I don't know. I don't know what they're doing here. What are they doing here? Well, maybe there's some instruction somewhere I'll come across. I'll keep working on this. But for now, what I need to know is I should really, you can kind of flip this ground thing right over to here, ground this, and then hook up a single input here. That would give you the single wire treatment. That would take the ground off of here. Maybe that's the whole deal. You're swinging the ground. When it's not on here, it's got to be over here, or it should be over here. I don't know, that's kind of strange. I don't think there should be a ground at all when you're using these two. Okay, I'm just going to leave it as a question mark to be sorted out a little bit further. Oscillator, transformer, police. Call the police. Broadcast, shortwave. Whoever did this schematic, his lettering is not as good as it could have been. But you know, this was, I believe, this schematic would have been drawn up by a student going to a college that taught radio technology, Radio College of Canada. And does it say it on here again? Doesn't say it. I thought I saw it. Yeah, there are Radio College of Canada. what they would do is they would get radios from all the manufacturers. I think there was a big thing going on, and the radio would come in, and the students would study the radio and eventually develop these schematics by studying the radio, and then these schematics would be published, and that's how the school made some money. They stay afloat. Something like that was going on. So this would be student drawn. Is it signed off in any way? Well, we don't see it on here, but it could have been signed off. Those signatures haven't carried through, but you think there'd be an instructor who would sign it off. I don't know how they do this to make sure it's correct, because that's a monster. I mean, you could easily make mistakes in here. I mean, that's something to keep in mind too. Okay, very good. What's all this showing? Hey, any voltages written on here at all? Do we see anything like that? 6.3 volts. I don't see any. I just see the heater voltage. Really, do you have to tell us that? What about maybe up by the tubes they've written? Yeah, there we are. 175 volts. 270 volts, 220 volts with 90 volts. This is good. And I don't have the pin numbers written here, but I can sort it out with a tube manual. Or I just look for, 220 and 90 on 2 pins. Just go around the tube and find the voltage. This is good. Okay, this is good. I like this, so I'm going to stop and have a coffee now. There's something here that's not lost on me at all, and that is, when I was a kid, I would watch cartoons like the Jetsons, and I'd see them flying around in their flying cars and robot in the house and all, and I would wonder, what the future will bring for me. And of course, what the future has brought for me is way beyond the Jetsons. Think about this for a minute. 1937, there's some guy about 20 years old, 22 years old, studying radio electronics, drawing this schematic with his instructor leaning over his shoulder. I'm assuming I'm correct in this story, as he drew it when he was attending Radio College of Canada. Now, what if he was sitting at his drafting table working away on this, and I showed up and snapped my fingers, and now he's here with me. He's standing here with me. He's gone from 1937 to 2023. There's a chance that 20-year-old's still alive today. It's a chance. And the first thing he would see is what you're looking at right now in the camera. He would see a lot of stuff that he would feel pretty comfortable looking at. Some of it he would say, wow, what's that? But it's when he got over to here, to my computer. And I should have left this up. And he looked at that. That's his diagram on this computer. At this point, I think a person would break down and begin to literally cry from the overwhelming impact of seeing this thing. 1937, no television. And then I would say, hey, watch this. And I would click, click, click. And a moment later, we would walk in my other room, and out of a machine would come this piece of paper. I think that person would lose their mind. I think they would sit down with a blank stare and try to understand, where is he? Is he still on the planet Earth? What has happened here? It's easy for us to forget how much beyond the Jetsons we actually live these days. Just the fact that I can print this thing is stunning. This was from 1937, and I'm printing it out of a computer and a printer. So I try to be aware of this as I am traveling around, because it makes me feel really good, because I am living in that future that I couldn't even imagine when I was a kid. We'd be better than Jetsons, and I'm not flying around in a flying car, not yet anyway. But I'm doing a lot of other stuff which is so futuristic, so far advanced. And of course, as you know, we're all on the edge of a huge explosion through AI. In fact, not on the edge of it, we're almost in the middle of it already. AI is already doing fantastic things for all kinds of people and science and all kinds of stuff. Fantastic. Maybe shortly through the AI thing, I will look at my computer and then I will sit down with a blank stare on my face going, I can't comprehend what is going on around me anymore. Yeah. You know, there's a lot of angles there when it comes to not comprehending what's going on around you. Okay, we're ready to go. So because I've determined that I can make measurements to ground, I will use my older meter here. I really like the pointer. I think, you know, yeah, when you read the digital voltmeter, you have to stop and think about what you're seeing. Whereas, so you have to use your sort of intellectual brain to kind of comprehend it. I don't like that spot. Put it up here. I don't like it up there either. Put it right here. That's good. Put it there. And of course, I just lost track of what I was talking about. So, ready for positive voltages. I saw 270 in that on the sheet here. And so probably the power supply, probably on the capacitor, it's 300 or more, but I got 500 on here now. Okay, I think we're ready. We're ready to turn it on. Volume. Look at this. Here's the knob. There's a shaft going all the way to the back to pick up the volume control. Why did they do that? Well, I mean, why wouldn't they have mounted the volume control up here? I actually thought this was a better way. Wow. No wonder this is hard to turn. There's actually, look at this. I don't know if you can see it here with this camera. Well, let's switch cameras for a moment here. Just show you something they had to do because of that long shaft. Look at this. Look at the linkage there. They had to come up with. Huh. It's not even really attached all that. It's just kind of forced in there with a shim. Looks like. Huh. The secret number. 159. That's probably the number of the fellow who did some inspection or something on it there. I don't know. Okay, we're ready to go. I think we're ready to go. And the power on. Do I have the switch on? I don't think so. No, I can see the voltage here is fairly high. If I put the switch on, it should drop. There it goes. Ooh, that's an ugly sounding switch. It's a pretty close short circuit right there. And the switch is rotating a little bit. Ooh, that's close. Okay, we have a chance to warm up. A little bit of volume. You can hear something coming out of it. Now, I am feeding it with a greatly reduced voltage, so that's maybe not the best way to test this. If I want to test its voltages, maybe I got to give it the full Monty here. So I'm going to turn down the main supply. I'm going to flip this up. When I do, the power won't go through the dim bulbs anymore. It's going to come straight here. Okay, that certainly brightened up the light bulb on the radio over here. So we're feeding this with probably around 100 volts now. Okay, so I want to go after the one capacitor that I believe is going to have the main B plus voltage on it. And that was the one. That was did I really sort that out? The wire was never exposed for testing. Oh! So that wasn't a shot of lightning, was it? No, I don't think it's possible. The sun is shining outside. I don't think that. There's just some noise in here. So if this is the power supply resistor, then at one end will be total B plus, and at the other end will be grounded at the other end, wasn't it? Let's start here. Looking over here, there's nothing happening. Nothing happening. This is just moving ever so slightly. Nothing happening. That's just a little on the surprising side. Could go after a tube right away and see if we can find some high voltage on the tube, since I don't know where to poke around the power supply. Well, you know, let's look at that capacitor that I think is not grounded. What that would have voltage on the other end of it. There we are. Okay, we got something happening here. So that's 250 volts, you know, 500 scale meters straight up. 250 volts. There has to be B plus in here for the radio to operate at all, and it does. It makes noise. Did make no. I don't have anything on the antenna. Not making any noise. I'm not going to worry about it right now. Okay, let's go after a tube that's in the clear. That would be this one up here. I can get at the pins fairly safely, and I don't know which is which. I'm just going to go around one at a time and see what happens. So, going here. I can't see the meter from where I'm standing, so I do want you to be able to see it too. So what's happening is when my eye is looking this way, and then I have to turn my head to look over here, and that's when the voltmeter lead is going to slide off, and the video is going to become a lot more exciting. So now there's a whole bunch of pins tied together. They're almost certainly to ground. Okay, nothing happening there. And we'll come over here. This is just a crude look at. Okay, so we got almost the full voltage there. That's probably the plate connection. And we might find the screen right beside it. So there's a fairly low voltage here. That's 150 volt scale. I'm not quite halfway, so that would be like 70 volts. So if we look at that tube, and determine that's the 6K7. Look at the 6K. I'm going to have to put on magnifiers here. 6K7, 270. And I read, what did I read? I read like 230. And then the screen voltage on here, can you read it? I can't see it. 90. And what did I read? I read 70. And it could easily be the supply voltage to the radio is low. Normally I have another meter in here. See, this one is just coming up off 100 volts, so we are operating a little low. So it sounds to me like that's probably the correct volt, certainly in the range of the correct voltage on that tube. That says an awful lot about this. Let's see if we can get at the output tube, and the voltage there is supposed to be, it's got to be 256, what it says there. Let me look with a magnifier. Put this on the screen, 255. So 255 on the plate, the output tube, and there's a screen, and it's 275 on the screen, which is a little odd at first. You know, a screen voltage higher than the plate voltage. The output tube, oh, I'm not going to be able to do this, not easily. There's the output tube. There's the output socket. Output tube socket. Right under all that stuff. Oh my gosh. There's no way I'm sticking my probe in there. You have to put a tube extender on here and then measure at the top. A bit of a hassle. There's some other way we can do this kind of stuff. Well, what can I do? I can get at this tube here. This guy here. I think. Oh boy, oh boy. Okay, I'm trying to start with pin 1. Not that it really matters, but oh boy, going in there. Oh, scare me. Okay, I got nothing on pin 1. Pin 2. Nothing on pin 2. Pin 3. Yeah! Oh, I'm on the 150 volt scale. Okay, so that was about 140 volts. 140 volts. This is the the 6Q7 should be 175 on the plate, and that's it. That's all there is. There's a 175 on the plate. And what did I read? Let's try it again. This one. Oh. Good thing this isn't like a nuclear weapon I'm working on here. So that's a 150 volt scale, that's 120. That's a little low from 175. But again, it could be because the supply voltage is a little low. Let's settle the supply voltage question. So I have one of these guys that I normally have plugged into my cord here. I'm going to plug it in. And then I can read the voltage more accurately than this meter. And we can set it to a more normal range. I'm just going to pull the radio out. Put this in. If you notice, the ground prong doesn't touch anything. And this is going to tell me the supply voltage is 100 volts. Which we will adjust in a moment. Let's put the radio in. Might drop it slightly. And you have to wonder why it's dropping it much at all. There's something going on. I've got quite an extensive thing. Chain of stuff, not the least of which is a fuse right here. I've got a fuse in the circuit. I got lots of protection here from overload. Okay. Now we really want this to be more like 110. So we're gonna turn it up here a little bit. Okay, that's going to do the trick. Now we will take a look at that same voltage. We use it as the, what would you call that? The one that represents everything. Well, we're up over 150 now. We're trying to get to 175. Okay, so on that scale, that's 160. That's not bad. So it looks like the B plus is there for sure, and it looks like it's distributed. Okay, but I've only tested a couple of tubes. I haven't really. Oh my gosh, another tube. Would you believe it? It's way up in there. Again, the tube extender is the only way I'm going to be able to test it. Is it worth doing all that? What I'm trying to find is why is this weak, and I think I have to prove that each tube has its high voltages as the next step. So I think I have to do the tube extender thing. Okay, let me shut the radio off. Grab my tube extenders. I need to thank somebody for sending me these. That's a tube extender. The idea is you put that in the socket, put the tube in here, and then you've got all these contacts you can work with. Where'd this one go? This one broke, tube broken off. So, okay. Pull that off. Put this down. Next tube we would want to test, so we've kind of B plus here, B plus here, B plus here. There's really only one more tube. That's this one that really needs to be checked for B plus. So we'll do that. Set is off, power's off. Burn my fingers, not hot. Okay, power back on. Dim bulbs first, just because I'm a chicken. Okay. We're gonna give it so it's 100 volts right now with the dim bulbs. It's gonna go down 94, 89. No, I don't want it that low. I want it up. 112.6. Okay, volume is up a bit. That's good. I'm happy to hear that. Now, got a near short from the tube extender to the top of this capacitor that you can't see there. We need to stand on top of something so you can see better. See, I'm pretending you're actually here. Okay, we just go around kind of randomly, only you can't see the meter. We'll go around kind of randomly on these pins. See, the one pin is almost in the one terminal here is almost in contact with the top of this capacitor. Whew. Careful, Jim. I can finish that contact. So this went up just the tiniest amount. Odd. Okay, we'll go around. Now we're looking for the guy who's going to make that meter. I'm on the 500 scale, so it should go up like halfway or so. Hello. Got it? That's going negative. Can you hear it come out of the speaker? I was going to say that's the grid. That's not the grid. This is the grid. That's also going negative. That's what you want. Why the one's going negative down here, I don't know. Did I hit them all, or is there one more back here? Because I didn't see any high voltage. Okay, this may be the problem right here then. Let's go around again carefully now. So I'm going to put this on the 150 volt scale. Nothing there. Negative voltage there. Nothing there. So when I looked over at the meter, I saw the meter going down, as if I discharged it with this. It's tricky to discharge things with this meter. Yeah. I can't really interpret it as meaning something. This guy's negative. How come so many negatives? He's negative. Everybody's negative. There's something going on with this plate. Look at that. This whole thing is at a negative voltage. Put on the chassis. Oh, what's going on there? It shouldn't happen. Oh, for crying out loud, goofball! You know. No wonder I'm having trouble here. I didn't put the ground on. Okay, we're going to put the ground on the main chassis. This is going to give me better readings. Anything here? No. No. Okay. I think I'm ready now. Now we're going to find it. So let's put this back to the 500. We'll start here. Still see a little negative there. There's a positive. Did I short something there? You know, I'm being reckless. I was being reckless at that moment. Oh, short something. Okay, so on the 150 volt scale, we've got 75 here. 75. There's the B plus, and there's the screen. There's the B plus for the plate at just under 250, and the screen is quite a bit lower at 75. So 250, 75. 250, 75. And we're dealing with the 6A8. Right there. So this should have a 220 and a 90 and a 175. Should be 3 high voltage terminals on here. 175, 90, and 220. Yes, let's see. Is there really 3? I gotta do the whole thing again. This time count. starting here. Not. What do you call that? 75. To 20. 0. 0. 0. 0. There's the third one, and that's running just over 150. So that'd be the 175. So all the voltages appear to be there. So at this point, I could probably safely say all these tubes are receiving the high voltages the way they should. So you know what? It could be I just didn't hook up the antenna properly. You know, what did I try last time? So let's put the band switch on AM. Okay, that's A. That's broadcast. I'm going to take this ground off. Volume up. Okay, you can even hear a little bit without. Hang on to your ears. That's a lot louder there than there. So it looked to me like what you would do is you would apply the ground the way it is, and you would hook a loop antenna up to these two. Isn't that what I did when I tested it last time? Let's do it again. Let's do it again. So I'm going to get the lead from my loop antenna. It's right here. It's all ready to go. It's all ready to go. I'm going to have to run down and make sure the switch is set though. Let's put it on with... so it wouldn't matter which way you put these. Even though it's black and red, these really aren't in any way polarized. It's just either ends of a floating coil. Get on there. Stay on there. Now, where am I tuned? Where am I tuned to? So I'm tuned.
In Ontario, just 9 minutes from here. Visit distortion.com with the forecast, Joe Taylor.
Smoky, hazy transforms again today, and some showers and thunderstorms at times today and tonight. Our guaranteed high 26 degrees. It'll feel like 32. For the low, becoming partly cloudy overnight. Now tomorrow, Canada Day still has some smoky conditions. For today, the guaranteed high 26. Right now, we're sitting at 22 degrees with smoky conditions. City News time 11:03. Breaking news from Brampton, where Peel police say one person has died in a house fire near Airport Road and Countryside Drive. Brampton fire crews were called to the house around 10 this morning. Police say a male victim was pronounced dead at the scene. Drivers are being told to avoid the area. Stay with City News 680 for more on this developing story. And we also bring from Scarborough. We're bringing to a hospital after a GO train struck a vehicle. It happened around 10 o'clock on Finch Avenue between Kennedy and Midland. Paramedics say 2 people were taken to a trauma center with non-life-threatening injuries. A third victim has suffered from minor injuries.
That's not so bad.
They're being put on buses headed to Agincourt, Kennedy, and Union stations.
Let's try that tone control.
680 for more on this developing story. Well, a busy weekend ahead with our first official long weekend of summer. It's Canada Day tomorrow, and the weather could be better. Our moment correction.
That's right. Canada Day tomorrow.
To the long weekend moment.
Irene, I'm Judy. I'm sitting here in a park in Scarborough, and I gotta tell you, it's just gotten much darker out here. I know that Jill said there are some rain in the forecast, so what I've got, but certainly there's also smoke in the air thanks to the brutal air quality that we have. It's actually among the worst in the world right at this second, and that is impacting the amount of people that are in the park. There's still people around, but I don't think it's as many as we would typically see on a day like today, especially since the weather is nice but not too hot, and we're curious as to whether that will impact people's plans to celebrate Canada Day, because there is a lot going on across the city, including fireworks at Ashbridges Bay tomorrow night.
So that's pretty odd. Noticed that before. So what's happening there is the radio right now is tuned to the station you're listening to. With that antenna, because the antenna is tuned too, I tuned the antenna down to where there's another station, and that one started coming through. Now what that tells me is the front end of this radio is not very sharp at all, and it's gobbling in like a large bandwidth. If you have one station in there, well, that's what you'll hear. But if you have two stations in there, you might end up hearing both of them even at the same time if they're close together frequency-wise. That's weird. That's not normal. Is it a big deal? Well, I mean, could you just leave a radio like this? Well, with a tuned antenna like that, yeah, you can probably get away with this. With a wire out the back, I don't know what you would get offhand. And what about the shortwave bands? What about those shortwave bands? So I have to make sure an outdoor antenna is switched on down here. So I'm going to stop for a moment. No, I don't know if you can hear it or not, but our house air conditioners come on, so there's a little extra roar going on here. So my outdoor antenna is connected. Connected to this wire. Now, thinking about this. Well, if this is a ground, I suppose I could just put it on both and see what happens. I don't know. Well, let's try a few things. First of all, turn it up. Can we even pick up any broadcast radio with this? Tuning. Okay, we'll put this ground on here. See what happens. Got louder, I think. Tuning it. All that. There's a strong station right here. Well, okay. The loop antennas are way, way, way better for these radios. But let's go now, because I know the antenna is doing something, bringing in a lot of noise. Let's go up on the shortwave band. Come on over here. See this exciting dial lighting system here. So let's go to the top band. Volume up. Way up. I did pick something up here last time, but I thought it was really distorted. Around 9.3. Wow, it's hard to turn. Where'd he go? He was there. Fading in and out. Hair trigger tuning. Okay, let's play around with the antenna now. Did I blow something up just now? The radio's output just fading away. Could be fading because the station's fading. So So a click like that usually means you're draining a charge out of something. Doesn't like that. I think we should get the same result, red or black. We don't. I had to study that schematic a little more. So typically a radio like this is made for a single wire on shortwave to come up to it. Not two wires, not a cable, like not a coaxial cable. But I guess in some cases you could be bringing a twin lead up to a radio like this, but I don't think most people would. They would just be bringing a single wire. And that would be represent the single wire here. Receives. That's full volume. For comparison, I'll take another radio here. It's the same station now. You turn down the volume on the big radio. So all you're hearing is this one. This is its antenna. That's how strong this shortwave station is. This piece of antenna in my basement can pick it up. Now I'm going to hook this to the outdoor antenna. Not much better. Yeah. What's on this? Yeah. Okay, so I'm not terribly impressed with my outdoor antenna. There's a 16-mile long coaxial lead to get into my shop here, and it's never proven to be terribly good. But it is what it is. Okay. Well, on the basis that I haven't found anything really wrong with this radio yet, the next thing that would be suspicious is the radio properly aligned? So luckily I've got the instructions here. I've got enough information now. We can take a look at that. So I think that's what we'll do. We'll take a look at the alignment, and we'll do that tomorrow. I'm done in here for today. So thanks a lot for watching. I hope you're getting a kick out of this. I have a parade of radios of this sort coming at me here. So there's going to be lots of this kind of vintage of radio worked on. So don't forget to do that. I'll see you on the next video. Thank you very much for watching, and thank you very much for the super thanks. See ya.